Welcome back to the deep dive. When I think about the future of, like, air combat and fighter jets, it's crazy to think how fast things are changing. And back in March 2025, the U.S. Air Force, along with Boeing, well, they dropped a bombshell, the F-47. It's their sixth-generation fighter, a real game changer.
It is, and it's part of the NGAD program, this Next Generation Air Dominance.
Yeah.
We got a ton of great info from our listeners about this, in-depth articles, research papers, even some stuff on how China is approaching this whole sixth-gen fighter thing.
Yeah, a real treasure trove of information, so thanks to everyone who sent stuff in. So for this deep dive, I was hoping we could kind of cut through the noise and get down to the nitty-gritty. What are the F-47's real capabilities? What makes it tick? How does it stack up against potential rivals? We're going to try to answer all that for you.
Absolutely. We'll unpack all that and more.
Perfect. So first things first, let's talk about the F-47 itself. We're talking advanced stealth, the kind that makes it almost invisible to radar. Then there's the extended range. It can fly further than previous generations of fighters, and of course the speed. We're hearing it could potentially go faster than Mach 2.
That's right, potentially exceeding Mach 2. That's over 1,500 miles per hour at altitude.
Crazy fast. But hold on, it's not just about this one super fast, super stealthy plane. What makes the F-47 really interesting is that it's part of a larger system.
Exactly. It's not a lone wolf. It's more like the leader of a pack, working with other unmanned systems, particularly CCA's collaborative combat aircraft. These are like AI-controlled wingmen that can extend the F-47 sensor range, carry extra weapons, even act as decoys.
So it's almost like a team of robotic wingmen, right? And, this kind of technology doesn't just appear out of thin air. It's the culmination of years of research and development.
A decade of development, to be more precise. And your sources reveal something pretty fascinating: extensive secret prototyping. Both Boeing and Lockheed Martin were involved, flying these experimental X-planes under DARPA's Aerospace Innovation Initiative. Boeing's program started as early as 2019 and Lockheed's in 2022. Hundreds of hours of flight testing. That's how they de-risked the advanced technologies that are now in the F-47.
Hundreds of hours, in secret. That's incredible. It really shows the kind of effort that goes into these next-gen aircraft. So, design-wise, what's the F-47 like? I've heard some interesting things.
Well, the consensus is that it's likely to be tailless or maybe have canards. The main focus is on minimizing its radar signature, that's the stealth part, and making it super maneuverable, getting rid of the tail fin. That dramatically reduces the radar cross-section, making it much harder to detect.
Tailless. It's almost like a throwback to some older designs, but with modern technology making it work. Speaking of the past influencing the future, there's this connection to the X-36 that popped up a lot in the material you sent.
The X-36 was a tailless research aircraft from the 90s, a joint effort between McDonnell Douglas and NASA. It did 31 test flights, all successful, back in 97 and 98.
So why is a plane from the 90s relevant to a sixth-generation fighter in 2025?
The X-36, its whole point was to test ways to reduce radar signature and improve maneuverability. And guess what? The tailless design was key to both. No tail fin, less weight, less drag, smaller radar signature. The sources suggest that the F-47's design that focus on low observability and agility, it's building on the knowledge gained from projects like the X-36.
So it's like the F-47 is taking those concepts from the X-36 and pushing them to the next level. It's pretty amazing. Now, while the U.S. is developing the F-47, China's not exactly standing still. They're also working on their own sixth-generation fighters.
Right. The Chengdu J-36 and the Shenyang J-50, those are the ones to watch.
Let's start with the J-36. What do we know about it?
It's a large aircraft with a tailless delta wing design. It's reported to have had its first flight test pretty recently, in late December of 2024. There's speculation that it could have a combat radius of about 3,000 kilometers and a maximum takeoff weight of 55 tons. It seems like they're designing it to cruise at supersonic speeds without using afterburners, which would be a big advantage for fuel efficiency and stealth.
Wow, 3,000 kilometers. That's a serious range. What about the J-50?
The J-50 is smaller, with 2 engines and a tailless lambda wing design. It was also spotted being tested around December 2024. The focus with the J-50 seems to be on broadband stealth, making it hard to detect on a wider range of radar frequencies and integration with unmanned systems, much like the F-47.
So both the J-36 and the J-50 are tailless. It's like that design is becoming a must-have for next-level stealth, no matter who's building the plane.
It does seem that way. It points to a kind of shared understanding that tailless designs are the way to go for these advanced fighters. And both of these Chinese programs, they're part of China's two engines plan. They want to be able to build their own advanced military jet engines.
But the info we got suggests that the U.S. might still have an edge in some key areas. Where does the F-47 and U.S. technology in general have an advantage?
Based on the research, the U.S. seems to be ahead in artificial intelligence and network-centric warfare. That's the ability for different military systems to communicate and work together seamlessly. And probably most importantly right now, the U.S. has a lead in engine technology.
Engine technology. That's often what makes or breaks these amazing machines. What's the current situation?
There are some potential roadblocks for China when it comes to developing those cutting-edge engines. Their supply chains have reportedly had problems, especially for the special alloys needed to make those high-performance engine parts. This could mean delays for their most advanced engines.
So China's making progress on the airframe and stealth side, but they might be hitting some snags with the engines needed to really push those designs to their limits.
That's what it looks like right now. So let's dig a little deeper into those sixth-generation technologies that make these aircraft so advanced.
Yeah, let's do that. We talked about stealth, but it seems like enhanced stealth takes things even further. What's different?
It's more than just the shape of the plane. We're talking advanced radar-absorbent materials, and they're effective against a wider range of radar frequencies. Remember the broadband stealth we mentioned with the J-50. The idea is to make the aircraft nearly undetectable, no matter what kind of radar the enemy has.
Essentially making it invisible to a wider range of electronic eyes. Pretty impressive. And then there are those adaptive cycle engines. What makes them so special?
These engines, they're a real game changer. The U.S. has the XA-102 from GE and the XA-103 from Pratt & Whitney. They're called three-stream engines. Think of a normal jet engine. It has one main path for air. A three-stream engine has extra pathways, so engineers can control the airflow in different parts of the engine on the fly. This lets them optimize the engine for fuel efficiency on long missions or switch to max thrust for combat, all in real time. We're looking at maybe 35,000 to 40,000 pounds of thrust, which is a massive amount of power.
That kind of flexibility sounds like a huge advantage. How does it compare to what China's working with?
The WS-19, which is meant for their fifth-gen fighters, doesn't have this adaptive cycle tech. It puts out about 116 kilonewtons of thrust, which is roughly 26,000 pounds. China's definitely working on more powerful engines, maybe variants of the WS-15, which has even more thrust. But this adaptive cycle capability seems to be something the U.S. has a lead on right now. This could make a big difference in fuel efficiency and supercruise capability for the J-36 and J-50.
So U.S. engines might not only be more powerful when they need to be, but also more efficient and versatile. That makes sense for extending range and staying stealthy. Speaking of technology, let's talk AI. Artificial intelligence is going to be way more than just a helper in these sixth-gen fighters. It's going to be a partner to the pilot.
That's right. AI will be involved in everything from helping the pilot make decisions to processing data from all the sensors on the plane. AI can analyze huge amounts of information much faster than a human, spotting threats, tracking targets, even suggesting what to do in tricky situations. There have even been tests with experimental aircraft like the X-62A, where AI has actually flown the plane in simulated dogfights.
AI flying the plane in a dogfight, that's some next-level stuff. And it's not just about the individual aircraft, right? These fighters are designed to be part of a much bigger interconnected system.
Right, that's network-centric warfare. The F-47 and other similar aircraft, they're designed to be nodes in a massive network that covers everything: air, land, sea, cyber, even space. AI makes that kind of integration possible, letting systems share data in real time and coordinate actions. This is especially important when working with those UCAVs, those unmanned combat aerial vehicles that we talked about earlier.
So it's not just one fighter versus another. It's a whole team of manned and unmanned systems working together, sharing info, coordinating attacks. And the F-47 is supposed to be able to command these unmanned wingmen, right?
Exactly. The sources make it clear that integration with loyal wingmen and CCAs is a top priority. AI is going to be crucial for managing these autonomous aircraft, controlling their flight paths, coordinating their sensors, even telling them when to fire their weapons. This kind of manned-unmanned teaming really multiplies the F-47's capabilities.
Let's dive a bit deeper into AI and its impact on communication and coordination. How's it going to help in those super complex combat situations?
Just imagine, a modern fighter jet is already flooded with data from its radar, infrared sensors, electronic warfare systems, and more. AI is like this super smart filter that takes all that raw data and makes sense of it in real time. This gives the pilot a much clearer picture of what's happening around them, making it easier to make decisions and reducing their workload.
It's like having a genius co-pilot who's constantly processing information.
Exactly. AI can identify threats, track multiple targets with pinpoint accuracy, and even suggest the best tactical maneuvers based on the situation. And in some cases, with the pilot's approval, AI could even handle things like targeting and firing weapons.
And when it comes to network-centric warfare, how does AI help the F-47 communicate with those unmanned platforms?
AI is the glue that holds the network together. It makes sure that the right data gets shared between the F-47 and its drones at the right time. This lets them coordinate attacks, do complex defensive maneuvers, and operate effectively in those really tough anti-accessoria denial environments where the enemy has lots of defenses. The F-47's AI is basically the conductor, making sure the whole team works together smoothly.
So AI is what makes this whole family of systems concept work. It allows for a level of coordination that would be impossible for humans alone to manage. Let's get back to those engines for a minute. It seems like the U.S. has a real leg up with that adaptive cycle technology. Can you tell us why that's so significant?
The XA-102 and XA-103 engines, they're a revolution in engine design. By being able to change the way air flows through the engine, they can achieve a much better balance between fuel efficiency and power. In a real-world mission, that means longer range, better heat management, which is important for stealth, and overall, a much more capable aircraft. The fact that they used model-based systems engineering to develop these engines means they were designed for efficiency from the ground up.
And you said that China's current engines don't have this adaptive cycle feature. What does that mean in practical terms?
While their WS-19 engine is good, it's not as flexible. China's working on more advanced designs, but those supply chain issues we talked about could mean delays. This engine gap could have a real impact on the J-36 and J-50, especially when it comes to range and the ability to fly supersonic without using afterburners.
So even with those stealthy airframes, the Chinese fighters might not be able to fly as far or as fast without giving up their stealth advantage. That's a big deal. Okay, let's zoom out a bit and think about the strategic implications of the F-47. How's it going to change the game?
Strategically, the F-47 is all about maintaining U.S. air superiority, especially in contested airspace. Being able to fly long distances and operate in areas that are heavily defended, that's a huge advantage.
But cutting-edge tech comes with a price tag, and I remember reading about some cost concerns with the NG-80 program.
Yeah, back in 2024, there were reports that the program was being reevaluated because of rising costs. Some estimates said the F-47 could cost 3 times as much as the F-35 per plane. Affordability is always a big issue with these advanced weapon systems.
3 times the cost of an F-35. That definitely raises questions about how many they'll actually be able to build. So even though the technology is incredible, the price could be a limiting factor.
It's a balancing act, for sure. Meanwhile, China's moving fast with the J-36 and J-50. Even though they have those engine challenges, they're closing the technology gap. This could have a big impact on the balance of power, especially in the Indo-Pacific region.
It's a constant race to innovate. But you know, there was one thing about the F-47 that I found really interesting. It's the way they're using digital design tools.
Ah, yes. That's a really smart part of the program. They're integrating digital design and simulation into every stage of the aircraft's life design, manufacturing, maintenance, upgrades. They're basically creating a digital twin of each F-47 so they can test things virtually. This means they can roll out software upgrades much faster and even make hardware changes more quickly and cheaply. It's about making the F-47 more adaptable and easier to maintain over its lifetime.
So it's not just about building a great plane, it's about creating a digital system to support it. That could help with those cost concerns in the long run.
Absolutely. Being able to update designs, test new features virtually, and then quickly push those changes to the real-world fleet that's essential in today's rapidly evolving world.
Okay, so let's wrap this up. What are the key takeaways from our deep dive into the F-47 and the world of sixth-generation air combat?
The F-47 is a major step forward, potentially building on the work done on earlier experimental aircraft like the X-36. It embraces AI for everything from situational awareness to coordinating with drones. The U.S. seems to have a lead in engine technology, which could give the F-47 an edge over China's J-36 and J-50, but the cost of the F-47 is a big question mark.
It's a story of amazing technology, tough challenges, and a global competition that's only getting more intense. You've given us, and I'm sure all our listeners, a much better understanding of this new era in air combat. Thanks so much.
It was my pleasure.
And one last thing to ponder. Given how fast things are changing, what other breakthroughs might we see in the future? Could we see directed energy weapons, super smart AI that can fly planes on its own, or even completely new ways of fighting in the air that we haven't even thought of yet? That's something to think about until our next deep dive. Thanks for listening, everyone.